Okay.
Yeah.
So this week we'll try skyline. Yeah.
Okay. Skyline I've tried, but it seems quite hard.
I've got an idea on how to do it in ON squared complexity.
How?
So the idea is wait, how do I do this? Yeah. So the idea is I have I find n. I find where n first is. And n is guaranteed to have condition -1 -1.
Ready?
Right? And -1 is guaranteed to be n. Right? There's only one -1 -1. Then from there, I look to the right. Because we want the lexicographically smallest, I look to the right and find the furthest away possible place where I can put n-1. Right? If there aren't any, then I go to the left and I find the closest place where I can put n-1. Then I repeat the same process, but with the new point as the selected place for n-1. I look to the right. Can I put n-2? If no, I look to the left. I look through the left, find the closest where I can put n-2. Then I do again. Can I find n-3 at the right, like that? Right? That's ON squared. And that's time complexity is ON squared. Let's try that. Wrap I and in and I.
Why do you need power and GCD for?
It's part of the template.
Oh,
I don't know why I put it here actually. It's not been of use yet.
it should be in front, right?
Not I don't know. I prefer it to be at the back so it doesn't disturb me. Because sometimes I have to use functions, right? Like with segment 3, I have to write build, update, whatnot, right? So if I just initialize it first and then I define it at the end, then it's much cleaner, easier to understand.
Not much easy.
For me. Okay. Then we just find n-1. Find L. We can do that while we input. So we have in current. If Li equals to -1 and Ri equals to -1,
Curve.
current equals to I.
Yeah. This will be the max.
Yeah, that'll be the max. Then from there, we could have a Boolean array. Boolean VB with n 0. Then this current equals 1. Yeah, this is basically counting where we already have a number. We already have a specified height.
We already calculated it.
Yeah, they already calculated. So now while current is greater than or equal to 0,
Mm-hmm.
you know, while current greater than 0, not don't need equal, because once it's 0, it's just there. Oh, greater than 1, I mean this one based. The numbers are 1 based. Then while current greater than 0, we look to the right. We look through the right, find the furthest. So reverse for I from current continuous definition. You just have count. Oh no, actually we can just use a for loop.
Sure.
For I equals 0, I smaller than n, I plus plus. But we only have to do this n minus 1 times and remove the last one also, so n minus 2. Then we reverse from I plus 1, no, from current plus 1 until n minus 1, 1. If this j continue, if the largest from there is 9, then we put, okay, so if Lj equals to current, but because it's 1 base plus 1, yeah, that is all, right? Is that all? Yeah, that should be all, right? Yeah. Okay, so if Lj equals to current plus 1, current equals to j. This j, this current equals to 1. Great. We can do this one. All right. Bool found equals 0. Found equals 1. Break. If found, continue. Reverse for. Oh no. Now we repeat. Yeah, now it's still reverse for because we want the furthest. So reverse for j0 until car. Increment of 1. If it's visited, we continue. Same as previously. If Rj is equals to current plus 1, current equals to j. Count equals 1. Great. Yeah. No, we actually no, we don't need to. Yeah. What's this supposed to be? Oh, okay. Then
What's the difference between for and REP?
REP, it's already set from 0 until the specified number.
Oh,
This is my template.
okay.
Or you have a range. Yeah, so in this case, I can use reverse repeat j current. But this is 4, so never mind. Yeah. Yeah, that's all. But yeah, now we have to take note of the indices, the locations of our current. Vector int and size of n, default is 1. This current equals to 1, and current equals to, no, this current equals to 1. Oh, might as well just use ans as this. So we have ans all 0 at first. Ans current equals to
1?
no. We want the answer also, right? We want the actual number on it. So we need a counter which starts at n. Then we get the counter and decrease it afterwards. Bool found equals to 0.
Then we just need to find the next max.
Yeah. Find the next max. Huh?
But how?
What do you mean? What do you mean? Find the next max? 0, 0, 3, 4.
Huh? Why is it 0?
Yeah, because you see I did until n minus 2. Technically, I can just do until n. Yeah. All right. But we should remember 500,000.
But still,
500,000, is it too much? That's
if, for that, in that case, n squared still can't do it.
not fully, but we get some subtasks. We should get some subtasks.
Well, we didn't.
Okay, it's lower than I think.
TLE or one?
TLE even for subtask 1.
No, subtask 1 was big. You need to check for subtask 3.
Oh, subtask 2 also. So okay, subtask 2 there's some wrong answers.
Wrong answer. Check for the last one. Check for all the samples.
Oh my god.
Lexicographically small.
What is so wrong?
Lexicographically smallest. This should be lexicographically smallest, right? Because
Well,
the largest is fixated. So I find the the last position for the second largest to be in. Then I do the same for third last, then fourth last, and so on and so forth. Right?
So this was the problem.
Oh, some numbers are missing.
And some numbers are in the wrong place.
Yeah. That's interesting. Is it because of this notation? There's no way, right? Yeah, say something. If found, continue or repeat from current minus 1 until 0. If match J continue, if R J equal to count plus 1. Let's look at this subtask. So it's 6, right? 6 is fine. It's here now. Then it goes to the right. It has to look for 5. Where is 5 though? There is no 5. Where is it? 5. That changes something. Oh wait, why did I do until? Okay. All right.
What happened? What is the problem?
No, I fixed one problem. There's still another. The problem I fixed was that I loop from current plus 1 until n minus 2. N minus 1 here first. Yeah, but it's minus 1, as you can see. Greater than minus 1. Should be n, not current, not n minus 1. There's something wrong. There's something wrong with looping to the left. So there's something wrong here. Oh wait, I might as well just do. I might as well just do one full nested loop.
Huh?
Yeah, right. So I can just do rep in, then reverse rep jn, and then do all this. Right. Oh no 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 no. Oh wait, yeah. So if j greater than current, and that if j smaller than current, and this then we remove the boolean found. We don't even need this. This is a full this is a nested loop. We could bring this out. This current equals to j. What if we try this? Okay, let's look at this test case. So it's 5. 5. Then we go to the left, we reverse repeat. Go to the left. It's smaller than current. Rj equals to 9. Current is 8. Yeah, something wrong. I don't understand what's wrong. Okay, what if I try this? All right. Oh, 000. Oh no, wrong. I'm looking at the wrong one. 9080908076. Oh wait, is that? See? 90800765. 90800765. How is that possible? How can that happen? How does it change value from 4 to 3? What is this, right?
I think. Never mind.
When is I used here? Okay. Let me try. What if I try using what if I try using I to use? So we'll make this one based. I plus 1 1.
Why do you do like that? There's no difference.
No, it is different. This is from 1 until n. Previously was from 0 until n minus 1.
Oh.
Yeah.
Okay.
So now I is the current. I is current. But n is already filled out, so I don't need to care about n. And minus 1 should be, yeah, then current is n. Oh, but current is the index.
Yeah. True.
Then we don't really care about the actual value. Oh, no. Oh, then we don't need count. This just removes counts. Equals to I. Oh no, I said Yeah. But why is it like this? 4, 3, 2, 1. Zaruk. Yeah.
Well,
Okay, J is looking from 0 until n minus 1. Is that correct? Yes, because J is the index.
that is correct. There's nothing wrong with it. Or is there?
No, I don't think so.
Doesn't any
The quirk is here. This is the bug. Where did it go? Okay. The bug is in this section here. So from 4, the current is 8. Current is 7. Current equals to 7. Current equals to 7. I equals to 3. So we look through. Answer J, yes. Continue. Then if J greater than car, no. So it's smaller than car. If J and RJ equals to current plus 1. Is RJ greater than, oh, but this is already answer J. So confused. Else if J is smaller than current. Smaller than current and RJ equals to current plus 1. Huh. This is very weird. There's a here before this, but there's no here before this. Oh, current doesn't change.
what?
The reason that 4 is turning into 3 is because current doesn't change.
Huh? I don't get it.
Oh, because this permutation is invalid. Oh, doing it this way, the permutation can be invalid.
Lots of question marks.
Where?
I don't understand.
Oh, so you see in this test case over here, the 4 is mysteriously changing changing into 3, 2, and 1, right?
Yeah,
And
like
then,
spirits.
yeah, and then at the end it becomes 0, right?
Uh-huh.
So turns out it is because
What?
it's because current doesn't change.
Why?
I don't know.
Yeah, why doesn't current change? It is very obvious that current doesn't change, but why?
Current doesn't change. That if current doesn't change, that means that this permutation is wrong. Because this may be the lexicographically smallest up until 5, until 4, I mean. But after that, there is no spot for 3, 2, and 1. Or am I wrong?
Let me see this.
Yeah.
So what is RREP? Reverse repeat?
Yeah, reverse repeat. Reverse 4, reverse repeat.
From n minus 1 to 0, right?
Yes, n minus 1 to 0.
What GCD code?
What? What happened?
Never mind. This is hard. I don't get it as well.
Okay, now.
Okay. Wait, I kind of feel that we should split this case up into two cases, on the left to right, and on the left side of curve and right side of curve. We should do it individually. It's divide and conquer.
Yeah, suggesting recursion. Are you suggesting recursion?
Yeah, we should. I think it's divide and conquer.
Yeah, we could do that. Yeah, we could do that.
Maybe we can try it.
That's right. It will at least give us until n is smaller than or equal to 8. So what's it? Int f. Just put nothing first. No, I don't want segment 3. We want to implement this here. So we need current and we need ans. So we can make ans global. We can make ans global. The ans will be resized here.
Make left, right, and answer global here.
Left and right should also be
Global.
resized and globalized. Yeah. Can remove the comma 0. Okay. No. Yeah. Then in F, in current, we have current, which is this current, the index current. We have, let's say we have count. In count, which is basically our I. Right. Then we look through the two sides. We divide and conquer. We find every possible case. Is it? We find every spot where we can put n-1. Yeah. So we are repeat here. Okay. So what we do here, n is unidentified, globalized, and also n. So we reverse repeat j from 0 till n-1. Reverse. If ans j, we continue. If like this, we don't break. No, if we find one of these cases, we don't break. Instead,
divide and conquer.
We set it equals to count, yes. Yeah. Then we run f. What's it called? Return. No, we don't return f. We f in res equals to 0. Res plus equal fj count plus 1. Oh wait, no. It has to return a vector.
这现你们是足球题吗？
Boolean. Should return a boolean. Yeah, should return a boolean. So we said ans j equals to count if fj count plus 1, count minus 1, I mean count minus 1, return 1. Say this is the same. J return 1. Yeah. Then that's all. Return 0. If oh yeah, forgot something.
Maybe.
After this, so we set bool. Oh no, we don't change it. Okay, this is a problem.
True though.
No, it's still correct, right? Oh, but we want the lexicographically smallest.
Yeah.
Oh, but still, yeah, still, never mind. So, we just have to reset it back to 0 if it's not possible, right? Yeah.
So if count equals to 0, return 1. What happens now? What happens now?
What's next then?
Oh, yeah. So we set a dummy. Boolean dummy equals to f current is current, yeah. Why did I do that? In current, then count is n, starts with n. Oh, ans current equals to n. Bool dummy equals to f current n. -1. Each x ans cout x space cout backslash n.
Why do you need dummy?
We don't really need the Boolean function, right? The Boolean, the return 1 and return 2 is just to tell us whether this permutation that we have is valid or not, right?
Yeah.
Yeah, so we don't really need to use it to print out anything or what, right? We just need to use it to check whether we have to continue checking the next permutation or not. That's why we reset after if it's not correct, right? But apparently it doesn't work. It doesn't even do anything. It
Yeah.
works like this. That means it doesn't. That means it returns 0 right away, right?
True.
Let's try the dummy. Yeah, see all 0. It's 0. That means how can it be 0? Use I. So reverse wrap I from I'm so confused right now. Why is this wrong?
Me too. I also don't get it. How should I get it?
Okay. Let us try. Does it even enter here?
Divide and conquer.
It should enter here, right? Yes, it does. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. I'm guessing this should be 8 times. Should be 7. Yeah.
Getting annoying.
1, 2, 3. That's 10 also. That means it doesn't return 1. That is very weird. Comments one. Comments one. Count actually isn't used at all.
What?
I am so confused. Why do you think this happens? Okay, let's try something. Let's print out L and R. See if everything works fine. Should work fine, right? This works for some reason. This works. Very weird. So repeat IN. Mm, 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 mm. Yeah, it works. It works. It works. There's nothing wrong with the L and R. Something wrong with the function. See out current count backslash. What? How is this also? Wait, what? How can that be? Oh yeah, because it's not written 0 at all. That is possible. So first current equals to 7. Count equals to 3. What? Count equals it's the bottom of the chain. Oh. Put it up. Should be cascade. 3, 4, 5, 4,
I think
6, 5, 6, 6, 7. This doesn't help. What could possibly be wrong with this code? I don't see a problem here. Press, I don't press.
它只有立它的机器人就行了。
Oh my god, why is this wrong? Each X and X and is already that current count. If count is 0, then return 1. If ans I, we continue. If I is greater than current and Li equals to current plus 1. Unless plus plus. We could remove this. Something wrong. Oops, never mind, something's terribly wrong. What have I done? Oh, of course. Oh my God. It can never be. Still wrong. I'm so confused. Why is this so wrong?
Why do you have debug? Can I see your code?
We're trying recursion first.
Okay.
So what we did was we have two parameters in recursion, current and count. Current is the current index you are at, the current index of the previous number that you have already secured, right? That you have already secured. And then count is the new number you want to find the position for. So over here, I loop through, I reverse loop the whole 0 until n minus 1. If there's already a number on it,
So you make everything zero index.
Yeah.
Even the number also. But the input is one index.
yeah, I know the input one
Okay.
index. I make 0 index.
Okay.
Then okay, then if there's already a number, I continue because you don't need to care. Then if the index is greater than current, greater than the previous selected index, then and that that position L is pointing to current, right? Then I set
Can you just
And-
draw in on paper? Write on paper easier.
Yeah. So
RET is for loop from n-1 until 0.
yes,
Okay.
inclusive.
If
example-
you already secured the position, you continue, understand. If recursion, what is count again? What is count again?
Count is the current one we have. I think we should rename it. It's not clear.
Hmm.
Rename it shouldn't be current. This should be prev. This should be current. Current value. Prev index. Yeah. So what I do is here from here I run prev index equals to index of this 8, right? And current value is 8 minus 1 equals to 7. Right? Yeah. So what I do is if the current index I'm inspecting, right, is after my previous index, then I check, does it point to the current index,
Yeah.
previous index,
Yeah.
right? If it does, then I set the answer of that position to the number, to the value, right? And then after that, I check, does that permutation like this, is it valid?
Where do you check if it is valid?
Here, I recursion. This is this case. If it's 0, that means it's reached the bottom. Or forget to stack 'em up.
Why do you minus 1? In your recursion, why do you minus 1? Why do you call with current value minus 1?
The next value.
What do you mean next value? If it is minus 1, that means it's smaller value.
Yeah. I'm looking from n until 1 in terms of value. Because n is, you know where n is, right?
Yeah, you know what n is.
So I start from there.
Oh, okay, okay. So you basically call yeah, this looks makes sense. And your problem is you're inputting 0.
Everything written 0 for some reason.
In what scenario would you set this one? Yeah, this line. Oh no, there are another one.
This one written 0.
So meaning you cannot find a place for the number.
Yeah. Either that or the permutation isn't valid. Which is
Wait.
actually the same thing.
7 is the largest number in this case. You already secure it to be the very end. And you are supposed to find 6 now. Why can't you find 6? 6 is actually pointing to minus 1 and 7. Minus 1 and 7. So you make it 0 index, right? How did you make it 0 index?
L minus minus R minus minus if Li equals to minus 2.
Okay. You do it manually. Okay, Ken. Oh yeah. You do.
I could
Wait. What is this? Why?
to find where find where n is.
Oh, this is guaranteed, yeah.
Yeah.
Baby delivery. Okay, so that means the value here is minus 1, 6, minus 1, 6, which should points to this. Why is it not returning? Okay.
That come shop me give back this code. Oh, very sorry. Zari, you are my rubber duck. Zari, you're my rubber duck. Yeah. So that this program I input LR. I input the L and the R. I input the L and the R, and then I run.
Okay, so current. So what happened when you written 0, Mas? What do you do with the 0? Oh, this is Boolean word. This is returning Boolean word.
Yeah.
So when do you update the number to 0? Or is it default 0?
What do you update on 0?
This one. How come the content is 0?
Oh, the answer is only 0. Default of answer is 0.
Oh, yeah, okay. So default lah. Not because you written 0. Hanya I bingung. What do you mean by that? Okay. Boom, 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 boom. 0, 0, y, couldn't it find? I greater than previous index and I.
Still don't get it.
What is it?
So what do you mean by this line? Ri equal to previous index and also this line similar, right? Li previous. You mean the previous number, which is one number higher, one higher than your current
Yeah.
number,
Mm.
is located. That means you are making an assumption that that number that you are checking, the left and the right, sorry, the either left of it or right of it will be the one higher than it. It's not necessarily true, right? It could be 2 higher, 3 higher, 4
Okay,
higher.
that's why you're checking every permutation.
How do you do that checking? Sorry, I'm not following.
We look through the whole array.
Okay, so you start by calling this, right? Dummy, right?
Yeah.
Current n minus 1. So it receive a -1 here. Current value is -1. Previous index is current, which is n position. Then if current value equal to 0, return 1.
So I
Okay,
look through from 0 to n
you're
minus 1.
you're looping through from you're
From n minus 1 to 0.
if answer is already found for that, you continue. All right, that means now you are at 6.
Yeah.
The value is now sorry, what is I now? Oh yeah, I is now 5.
Five.
Sorry, 5, right? 6
Yeah,
minus
5.
1. I is now 5. Wait a minute. Oh, wait a minute. Oh, sorry. What is this again? What is I?
The index.
Oh, I is the index.
Yeah.
Why do you reverse from index from n minus 1?
So we want the lexicography smallest, right?
Yeah.
So it's best for the big numbers to be at the back and the small ones to be at the front.
Oh.
So we look from the back. If there is
Okay,
a
okay,
spot
okay.
there, then yeah.
Okay, so the current value is now 6, yeah? Current value is now 6. You're looping from the back, right? When you see this, okay, it's already filled up. So you continue. It's already filled up, so continue. Then you reach here. You want to fill up. Wait a minute. That means you want to fill up. Oh, then this is strange. I don't get it then.
Yeah, so when we look through the whole array, there are going to be some points that satisfy either of these two conditions, right?
Slowly. Let me think first. I think I get what you are trying to do. Okay. Yeah. Why isn't this giving you 7? Why isn't this giving? Oh, that. Wait a minute. No. Oh, this is the problem, I think. So when your I is 6 in this case.
Yep.
How come you enter here? Yeah, the previous index is. Sorry, the previous index is 6, right? In this case, previous index is 6, right? Yeah. Can you just see out the instead of see out thing here?
Yeah, inside the for loop.
Yeah, inside the for loop better. And maybe see out I also, right?
Right?
Hmm. No, it's and maybe we see out \n. Maybe we see out \n here.
What is
Okay. Sorry, button.
This one, right?
Yep.
Sorry, test case 2, yeah?
No, 3. You're looking at 2. Right? 0, 0, 0, 0, 7.
Oh, 2 you already passed?
No.
Oh,
Both
okay.
are wrong. Like
Okay,
just now we were
wrong.
looking
Okay,
at-
okay. So what is this? The first time, was it 566? Oh, 5, yeah, because index is 5 now. And previous index is 6, correct? Current value is 6, yes, correct. So where do you go? Where did you go to? Maybe we do this out here. What is this? Left. Left, yeah.
Answer.
It's quite helpful, huh? It goes to the right, which is expected, correct, yeah?
Yep. This actually left. No. This is left.
Huh?
This is right. Because I is greater than pref in. So this is actually going to the right. This is going to left. It just switch. Yeah.
No, I mean, I'm looking at the right. See, I'm checking the right, huh?
You're checking the right from the perspective of I.
Yeah, that's what I mean. That's what I mean. Doesn't matter,
that's what you
whatever.
mean.
Whatever. So this is going here, which is correct, yeah? This is what we want.
Yep.
Then why isn't ans I equal to 6 if it goes here? Six five, yeah, it's 6.5. So that means your ans I is re-updated again after by something else. This one maybe.
Yeah.
Why? Why do you set to 0? What is this for? What is this ans I equal to 0 for? It's meaningless, right?
No, it's not.
Why would you want to reset to 0?
If we've reached here, that means that ans I equals to current val is not possible, right?
here?
Whatever permutation that has
Lower there.
equal to current val and before.
Okay, then explain this line.
This line is running whether this line is checking whether it is valid to find any permutation with current val minus 1 and the new index of the previous index. Right? It's checking the it's finding the position of current val minus 1.
So you go all the way. If it doesn't find, then you backtrack. Yeah, that's what you're thinking.
Yeah.
Go inside on this.
That's the search.
Yeah, depth search. This is depth search. Yeah, right. This will become depth search. But then when you go back, when you go back, could it be that you're overwriting yourself and like ruining yourself in the process? Or is it not possible? Okay, why don't you do this? Okay, looks like your logic is correct. Why don't you print the answer every time you call? So every time you run this loop, chances are you updated answers, right?
Yep.
What if you just print answer all the time? Remove comment out all the C out.
On this.
Yeah. This one was
The
the answer. Okay, now copy this and put it in
Here, inside.
every time you inside.
front. Okay, no. The front already. Yeah, it has to be at the back.
Yeah, first you will update, right?
Then I update. Then it says selection 0.
Yeah. Why?
Because it doesn't update everything. There's some missing.
Yeah, why? That's the question, why? Why is your depth first search unable to figure out the permutation? Have you ever found 6 to be in the right position? Can you see? Is 6 ever be in the right position?
Yes.
There is. So when 6 is in the right position, see, you
It's the
managed
right
to find
position.
6, 5, 4, 7.
Then I change to 0.
But then why are you not able to find 2, 1, 3? That's the question. So that means when you reach this point here, somehow you fail to identify that 3 can be here. Right? That's the problem, right? Why? Why?
3 points to 4. Oh yeah, of course. Oh.
It could be higher number, I thought you, right?
Yeah. So we have to take note of the current max val. If ans I, instead of just continuing, we have a current. In current max equals to, this is just the index. Yeah, so in current max equals to prev in. This is only for this section because this section is just looking at the left. Current max. Just current max. Doesn't make a difference. Instead of just continuing now, we set prev in equals to I.
I don't follow.
Oh, current max equals to I.
May your logic better.
No, it doesn't work.
I don't follow actually.
It only works.
Progress.
Oh, it doesn't work for surplus 3 now. Is there a different problem for surplus 3?
Okay, all right. So subtask, but we were looking at subtask 3.
Oh yeah, we were. Oh, now it goes here. Oh no, that's wrong. That it should be.
Now it's the other way around. Now you cannot feel the right. Somehow you are not feeling the right. Explain why you are doing this current max previous index. Current max. Why would you set this to this? I don't get it. Why? Why would you do that?
So while we're looking from the back from n-1 to 0, we want to find the largest number that we have passed yet, that we have passed by already. Except when it's on the left of prev in, but it's prev in because we are looking to the left. Oh, but there could also be larger numbers after prev in. Oh, yeah.
Should you use set instead?
How do we use that?
So those numbers on the right that you know,
Yeah.
all of them are larger than.
It's not always on the right.
Oh yeah.
Spread out. This reminds me of segment 3. We can use segment 3 for this, but I don't know if it's overkill. We basically want to know where we already have ans I. Right? Ans I can be treated like a Boolean vector. So we basically want to know what is the closest one to this index, to this current, to this I, to I. If I is greater than pref in, what is the greatest J such that ans J is not equal to 0 and J smaller than I, right? And if I smaller than pref in, what is the smallest J such that ans J equals to 0 and J greater than I?
I'm not sure if I follow, but since you somehow passed 2 test cases, why don't you try submit? Because you got some partial point.
I don't think so. Oh, there is one subclass. No, never mind, do it later. Subclass 1 is always 0.
Subclass 2.
Subclass 1 is always 1. Oh, you got subclass 2?
Yeah.
This one's wrong.
That's 2.
How's your progress?
Not so well.
Anything wrong?
Yes.
What is wrong?
The recursive function does not work.
Yeah.
Just as well.
No, it's not about the tally. We're focusing on subclass 2.
Oh, but, okay.
Subclass,
You solved that 2. Oh, yeah.
Yeah, subclass 2.
How did you solve subclass 2? For subclass 2, you can just do n cube, right?
okay.
Yeah, subclass 2, you can just do n cube.
For subclass 2, you can even get a n to the power of 4. It doesn't matter.
You can try every permutation actually.
Yeah, you can just
So try
brute force everything. Brute force every single permutation you have. That's n factorial, but still very good. It's only 8. But I use this method, which is O(n) squared.
Yes, but
Oh, it's a simple splitter. I can actually get a subclass 3 as well.
oh my god.
Let me see your code.
So
But the problem at the hand that we want to solve is not how to solve subclass 2, but why.
yeah.
I see.
Okay, let's
Why is the recursive function wrong?
yeah, let's go back. Let's try to debug again and see.
I used it as, can I say, divide and conquer method. What do you use?
Same. Trying to at least.
Then what do you divide and what do you divide? How do you divide?
I divided by all possible places where I can put the current value minus 1.
Maybe I'll share my screen.
Okay.
Sure.
So
Yeah.
it's something like this. Divide and conquer. So DAQ. Don't ask me why I did it like that. First of all, if left and right is the same, of course, just return. Left and right are the limits for the current conquering part. And I divide it into the left part. I mean, this is the right part. This is the left part.
Okay.
Actually, I don't feel that I even need this. Do I? Yeah, I don't need it.
If Li minus 1 equals to current, what is left, what is right, what is current?
Current is the same as yours. Left and right are the limits for the current divide and conquer. So right, if it says 1, 2, 3, 4, 5, for the divide and conquer, we will make this the left part and this the right part. When we make this the left part, we'll just ignore all this. So the right is for the limit, to kind of throw away all these things for the limit. Yeah, that's the divide and conquer. The right will be here. Right will equals to 3.
Okay, and then what you're checking is if it's equal to current.
And then I put the right before the left so that it can lesser, graphically smallest order. Can I
And
see code?
Your result is you don't get wrong answer, you only get TLE. Yeah? Can we see your result?
Only get TLE.
Okay, so that means your logic is correct.
The logic is correct, just that I need to speed up.
Yeah, maybe you can do memorization. Try memorization first.
How? It's divide or conquer. I can't memorize on that.
Yeah, that's a good point.
Divide or conquer cannot use memorization.
I still don't understand simulation. I pretend to understand.
I kind of feel that my method is a bit different from yours. Maybe not.
It is different from mine.
Maybe you share a screen? I see how you do.
All right.
So what do you do?
So, and in the base case of the recursive
What's
function,
curve wall?
current val is the current is current. No, it was count. Current val is the current value that I want to put inside the answer. I want to
Find the place.
find the place for it. Yeah, best place for it.
Oh,
And prev index is the previous the index of the previous of current val plus 1. Yeah, current val plus 1.
So this is the part that I don't understand. Yeah. So if a number that is
curve max.
from the right, if there is already number in that position, why do you set current max to that? I mean, it's not necessarily max, right? It could be smaller value. Oh,
Yep,
impossible. Yeah?
Well,
It's impossible to be smaller value. Yeah.
Good. No.
I understand that.
Looks good. Oh yeah.
Yeah, the problem is this current max is supposed to only be used for when you're looking to the right.
Oh,
Okay.
so TLE?
Remember just now I
No.
switched this to current max.
Is it TLE? See if it's a TLE.
It's all TLE. Oh,
Okay, good.
yeah.
It's all TLE. Now memorization, because you are doing recursion, so you
I
could
told you you just need a small speed up.
I can't do.
You cannot?
memorization.
You
Yeah,
can speed up.
it's because it's all a different permutation, right?
It's a very easy speed up.
There is no overlap.
It's actually a very easy speed up you can do.
Really?
what?
Very easy.
Which is what is the speed up?
Left and right limitation.
What do you mean left and right? What do you mean by left and right permutation?
Like what I did.
Limitation.
Oh, limitation. I don't think will be much. I don't think will be significant enough. The difference.
Can you now start printing out? Printing out again and commenting on the C out. Now, can we see this just now that we keep on failing this one, right? Now you are successful.
For one
Yeah.
subtask. And the next one is actually easy to get as well. I admitted.
Here you couldn't. You try to put 6 here, you couldn't. You try to put 6 here, you can, and then boom, 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 boom. Yeah.
Wait.
Yeah. Wanna go to your room?
Yeah, I don't want to. Sorry.
Yeah. This is depth first search, yeah. Depth first search for the permutations, but you prioritize the large number first and from the right first. But still, effectively, in worst case scenario, you're testing every permutation, right?
Yeah.
So this is still ON factorial complexity. Of course, it's TLE in some cases.
Special.
But somehow you could pass test subtask 1 and subtask 2, yeah.
No, subtask 1 is.
8. 2 is only 8.
Yeah.
The maximum n is only 8. So if you get the method correct, obviously you're gonna get 2 correct.
Oh, subtask 1 is, yeah, subtask 1 is everything sorted.
Yeah,
So
so
you actually treated it separately, yeah, subtask 1, eh?
Yeah.
Okay.
yeah. You get another free 10 points.
But this is ON factorial, that's why you can only solve subtask 2.
Yes.
Okay, that means both of you are sort of done, I think, for tonight. What you have now is a solution that is, yeah, practically is ON factorial, right? Even your divide and conquer, William, I think it's still ON factorial because effectively you will have to test every permutation. You said it yourself, you cannot memorize. If you cannot memorize, that means, yeah, effectively you're actually trying every single permutation, right? It's just that you split, you limit left and right, but at the end of the day, you still have to do the same number of permutation like is. Yeah. So I guess enough for tonight. It's 10 p.m. I think it's good that you solve 2 subtasks. Try again this weekend. Okay.
Okay.
All right. Have a good sleep.
Maybe bye.
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 See ya.
See you.